Hello. Today we're going to do 2.6, the derivative. We're going to start from the problem of slope of tangent line. Showing the graph, you can see a curve f of x. Our task is to find the tangent line and the slope of tangent line at one point P on the curve. If you still remember the formula for the slope, it says right over wrong. We need 2 points to calculate slope. In other words, suppose the 2 points we have are x1, y1, the x2, y2. Then we can take the difference quotient y2 minus y1 over x2 minus x1 to calculate slope. But in the case of tangent line, we only have 1 point P in the problem. So we cannot use the formula directly to find the slope in this case. But since we learned the limit, we can use the 2 of limit to find the slope. What we do is we start from a secant line PQ, where Q is another point on the curve. And then we calculate the slope of PQ, and we take the limit to get the slope of the tangent line T. Suppose the coordinates for P is x and the f of x, and the coordinates for Q is x plus h and f of x plus h. So the slope of PQ will be equal to f of x plus h minus f of x over x plus h minus x. If you cancel x in the denominator, then you're left with h. So then we can rotate the secant line PQ around P toward the tangent line T. As PQ gets closer and closer to the tangent line T, the slope of the secant line PQ approaches the slope of tangent line. So we can take the limit of the slope of secant line PQ to get the slope of tangent line T. So in other words, the slope of T is equal to the limit of f of x plus h minus f of x over h as h approaches 0. This limit is defined as the derivative of f, and we denote it by f prime. So the derivative of a function is the slope of tangent line geometrically. So let's use the definition of derivative to find the derivative of some simple functions. The first example we have here is f of x equal to 3x plus 5. So we just use the definition for the derivative. F prime equals the limit of f of x plus h minus f of x over h as h equals 0. So you plug in x plus h for x in the first place on the top of the fraction. So you get 3 times x plus h plus 5 minus 3x plus 5 over h. After simplification and some cancellation, then we are left with 3h on the top. And then we can cancel h in the numerator and in the denominator. We get this 3. So the final answer is 3. So that's the derivative of this function. Let's do another one. This time we need to find the point on the graph of the function f of x equal to x squared minus 4x, where its tangent line is horizontal. So this is a quadratic function. We need to find the point on the curve so that the tangent line is horizontal. So remember, because the slope of tangent line is derivative. So if we can find the derivative of the function, then we find the slope of tangent line, and then we can set that equal to 0, because we're asking to find the horizontal tangent line. So starting from the definition of the derivative f prime equals the limit of f of x plus h minus f of x over h as h equals 0. So again, plug in x plus h for x in the first place. On top, we got the x plus h squared minus 4 times x plus h minus parentheses x squared minus 4x over h. You can expand x plus h squared and multiply out with x plus h. After the cancellation on the top, we are left with 2x plus h squared minus 4h over h. And again, you can divide h in the denominator, and we get 2x plus h minus 4. And then we take the limit with h equal to 0, we got 2x minus 4. So we need to find the slope of the tangent line equal to 0. So we just set 2x minus 4 equal to 0, we get x equal to 2, and then f of 2 will be just 2 squared minus 4 times 2, that's a negative 4. So that's the point on the graph where the tangent line is horizontal. Okay, we discussed limit and derivative. So we can talk about the relation between the differentiability and the continuity of a function. And it turns out that a differential function is continuous. So when a function is differentiable, then it's always continuous. But when a function is continuous, it does not guarantee that it's differentiable. So on the graph, there's 3 cases where a function is not differentiable, or the derivative does not exist. The function f is not differentiable at x equal to a, x equal to b, and x equal to c for different reasons. At x equal to a, fx is not continuous, so it's not differentiable. Okay, so to be differentiable, the function has to be continuous. At x equal to b, fx has a corner on the graph. In that case, the function is also not differentiable. You cannot draw a tangent line at the corner. At x equal to c, fx is also not differentiable because it has a vertical tangent line. So the slope of the tangent line is undefined. So the derivative is not existing. So that's the 3 typical cases where a function is not differentiable. So we're going to continue next time with 2.7.